In this video, I will share my experience of using Mbed TLS with W5500 chip. So this Mbed TLS, it is a SSL and TLS library for and this is designed especially for embedded systems. So it can run in a small amount of space. It requires less amount of RAM, and this is designed by ARM. And previously it was part of the Mbed OS, that is why the name Mbed TLS. But now the Mbed OS has been discontinued by ARM, and so this project, this Mbed TLS project, now it has been moved to this trusted firmware project, this thing, trustedfirmware.org. So now Mbed TLS is part of trusted firmware organization, and I will use this library, this framework, for creating encrypted connection between my client and servers. So basically this library will help you create secure versions of the protocols, like a secure version of HTTP, which is HTTPS, and also the secure version of MQTT, which is MQTTS. And this is a free and open source library, so we can use this in our project without any problem. This is licensed under Apache license, so we are free to use in our project. And there are few other alternatives to this Mbed TLS also. Let us see. Let us search for this, that is embedded SSL TLS library. So we have alternatives like Wolf SSL. As you can see that we don't have much alternatives, so it is good idea to go with this project because this Wolf SSL, I think it is proprietary and it is a paid software. So here I am on the page of home page of Wolf SSL. Let us see the license, and they say that it is open source. Wolf SSL, Wolf Crypt, these library are free software. Downloads and may be modified to need the users as long as the user adheres to the version 2 of this license. And here we can see that it is GPL licensed, and in short, GPL license, any project which is using GPL license, we are allowed to use the code from these projects in our project, but we have one important condition, that we cannot close source our that derivatives or our works. So we have to, if you are working on open source project, then this is okay, we can use Wolf SSL, we can comply with this license because we are publishing our software also as open source GPL license. But we cannot use this in our closed source or commercial project. This GPL does not allow for that. It allows for commercial software but not closed source software. For that we have to go for the commercial licensing. And business and enterprises who wish to incorporate Wolf SSL product into their proprietary applications or other commercial software products, the commercial license is available for $7,000 per end product. So this is quite heavy fee. So rather going for this, we are going for this one, that is Mbed TLS, and this is also supported by this our ID, that is STM32 Cube ID. The support is good. It our STM32 Cube ID or the Cube infrastructure, the Cube projects, the Cube framework, they internally use this Mbed TLS as their backend for this processing all this HTTPS and other encryptions. They use Mbed TLS. So this is a good option. Let us go with this. So to get Mbed TLS, just go to your search engine and type Mbed TLS like this. So in the top you might get an paid ad for this Wolf SSL. So after that you will get this thing, that is the GitHub repo for this project, that is Mbed TLS. But and also the Wikipedia entry, The documentation is hosted here in readthedocs.io. I don't know why they have hosted here. And you will not find the official web page of this project Mbed TLS anywhere in the top ranking pages in Google search. Don't know why. So here in the very bottom, I think the last link, the 10th one, it is this one is the link to the official web page of this project Mbed TLS, and here you can see the ad for Wolf SSL. Let us see. Go to the Mbed TLS. So this is the home page. You should bookmark this page and keep it handy while we are working on this integration project. And one important thing I will tell you, that this kind of encryption library, cryptographic library, and supporting the full standard, that is the full TLS version 1.2 or 1.3, they require a lot of work on the library side. So these library are quite heavy and takes lots of flash memory, because they have to implement different type of this cryptographic algorithms. Then only they can support the different kinds of server, because there are lots of different cryptographic these algorithms, and every now and then they are depreciated and new these algorithms are developed, and for the previous compatibility they have to keep the previous algorithms also. So these libraries are very heavy on flash memory. So that is why I have changed my microcontroller. During all this course I have been using a microcontroller called this one, STM32F051. So this was a very basic microcontroller. This was a very basic ARM based microcontroller, and the reason was that we are creating low cost product. That is why I have chosen this microcontroller, because it is very easy to implement Ethernet in a high cost microcontroller, advanced microcontroller. But that is not the motive of this, or the motto of this course. The motto is to integrate Ethernet in a lowest cost hardware that is possible, and provide Ethernet and internet connectivity to almost every kind of, even the cheapest hardware. That is the motto of this course. That is why I have chosen a very low cost and basic microcontroller, which is available at a very low cost, to demonstrate that even this kind of small microcontroller can have full Ethernet and internet connectivity. So I was using this microcontroller. So here I am on the home page of this microcontroller, STM32F051R8. So as you can see, this is only a 48 megahertz microcontroller, and it has you can see that this one, it has 64 KB of flash memory and only 8 KB of RAM. So when I first compiled my very first project using Mbed TLS, it was taking nearly 64 KB of flash memory, and that was also that it was not implementing the latest encryption algorithms. And when I enabled the latest encryption and algorithms that are used in today's date, that is 2025, so the flash consumption increased more, and it reached about 100 to 150 kilobytes of flash memory. So definitely this is not enough. We cannot fit a 150 KB firmware on a 64 KB flash anyhow. So I'm talking about the debug builds of those project, not the release build. Release builds are much smaller than these debug builds. But even we need a microcontroller in which we can debug the code. So that is why that is also important, that we should be able to create the debug builds of the project also in that microcontroller, because debugging is an important step in firmware development. We cannot omit that. So I have chosen another microcontroller for the rest of this course, which will use TLS connection or SSL connection, any kind of secure cryptographic connection. For that I have chosen another microcontroller, but I have not increased the specs too much to increase the cost, and to keep the motto same, to create Ethernet and internet connectivity in smallest and cheapest hardwares. So this time I have chosen this board, and this is a made in China board, Chinese board, a very low cost board. In India I have purchased it in less than I think 3 or 400 rupees, which is less than I think $4 or $5. So still this is very cheap. So you can get this in less than $5 anywhere in the world, I think below that only. So this one is featuring a chip called STM32F401. So this is as ARM Cortex M4. This time I've gone with this M4, and this chip here you can see, this is the chip. And here I have given my this title, hardware setup for STM32F401 CC Black Pill board. The name of this board is Black Pill board. You can search this and you can purchase it from eBay or AliExpress, any online website, even amazon.com. And this one I will be using for any SSL and TLS based projects. And let us have a look at the specs. What are the specs of this microcontroller? And here we have 256 kilobytes of flash, which will be enough to store simple SSL based firmware, because I have told that basic SSL firmware takes around 100 to 150 KB, so less than 200 KB at max. So this will be a plenty for even such projects. It has 64 KB of RAM. This is also good. Processing speed is also good, 84 megahertz. It has 3 SPI ports, 3 UART port, and inbuilt crystal it is coming with. Here you can see this black thing. This is the crystal oscillator. This is the high speed crystal oscillator for the main microcontroller, and this one is the low speed 32.768 kilohertz oscillator for the real time clock. And we have some onboard peripherals on this board, and this is just a single LED. And on the back side of this board we have a this flash memory. Here you can see, but it is not populated. But U3, here you can put a flash memory, a SPI flash memory, which is of 25Q series, 25X series, whatever SPI flash memory you can put here, solder here. And it is, if you see the schematic, it is internally connected to the SPI1 port. Is connected to the SPI1 port, and we are having 3 SPI ports, so this is not a problem. We can hook up other SPI peripherals like our W5500 on another SPI peripheral. So this is also good, having 3 SPI peripherals. And in this document I have also given the clock configuration, how you can configure the clock properly for this board, for this crystal oscillator and everything, for the CPU frequency. And everything I am putting in this document, and I am also sharing the link to this document, so you can easily access this document, and you can also follow my step to get Mbed TLS working on your system. So here is the summary of this clock configuration. When you download this file, this project, you can zoom and see here, go through this diagram. So basically my uh, uh, aim is to get this 25 megahertz from my external oscillator and configure this main clock source as PLL clock source and get 84 megahertz. That is the full speed of this microcontroller. And here I have also mentioned my this connection, how I have connected my W5500 module to my STM32 board. So you can go through this table and make the connection, and after the connection your setup should look something like this. And this is my setup. In the center I have the microcontroller board, and then I have this W5500 module which I have connected to my microcontroller, this microcontroller board. And I have not used these male and female cable because those are bit unreliable and I don't like them. So I have just directly soldered this wire from to this my microcontroller board, and also to this W5500 board. Then I have applied a little amount of this hot glue here to make this connection even more sturdy and firm. Now these are tightly coupled, my microcontroller and my Ethernet controller. And after that I have connected this ST-Link dongle here to this debug port. Here you can see in the very right hand side of this board we have the debugging port, which has the connection like serial wire clock, serial wire data IO, DIO, and ground, all this thing. So I have used this kind of dongle. And finally I am connecting a FT232, this board or module here, and this is the USB to serial converter or USB to TTL level serial or UART converter. So this is used to view the debug messages that my microcontroller is sending, and I have connected this to the UART2 port, UR2, and I am using the baud rate of 115200, and here I will connect my USB port and I will connect to my PC, and in my PC I will use a terminal application like real term and view all the messages, the debug, the diagnostic messages that my microcontroller is sending. So this is my entire hardware setup that I have used to test Mbed TLS on STM32 and STM32 and W5500 platform. Now let us start the coding part. For that I am using STM32 Cube ID and I'm using the latest version. My version is version 1.17 or 1.17.0. So I better recommend you, if you are replicating my steps, please use this version only. And if you are having a previous version of this ID, please upgrade to at least this version, then only proceed. And in this video I will not create the entire project from scratch. I will start from a template project that I have created for this hardware. So everything is configured in that template project. It has the W5500 drivers, the SPI drivers, everything properly configured. So it is just a copy and paste and you can create a W5500 IO driver based project for this platform. Everything will be properly configured and working, and here is my template project. So I have a template. This is a template for this microcontroller, that is F401. So I will start with this one. I will just copy this one and paste it here to create a duplicate, a copy of this directory or the folder. So here I have the template copy and I will rename this from template to this thing. I will name it TLS client for F401. You can name it as per your convenience. After renaming the top level directory name, we will go inside this and we will load the .c project in our STM32 cube ID. For that I can just double click it while my cube ID is open here. So it will blink in open orange like this, and it will uh, I think due to that this pop-up, it has not imported the project. No, where it is. Let us try once again. Go to the STM32 cube ID. Successfully imported. We have successfully imported the project into the workspace. So where is our project? Let us see where it is. It will still be called template in our STM32 cube ID because the project name has not been changed yet. But you can get the clue from here that it is inside the TLS client dash F401 that we have just renamed our project. So the first step is to rename this to something meaningful. So first time we renamed the just the top level directory from our Windows Explorer, and now this time we are actually renaming the project inside STM32 cube ID. So two times this step is required, and there we will rename the actual project like this, and we have to make sure that this update references it is checked, and we will enter a new name here. like this, TLS client F401. Perfect. It is renaming everything within the project. It is kind of refactoring the project. Completed. Now our project is renamed like this, TLS client. Perfect. Now we can. So this is my template project which is configured for W5500, and it is having a pre-configured, properly configured Visnet IO driver installed inside it in the project. And but you can see that one this file is not renamed. This is the launch configuration, and this launch configuration is used to launch the debug session using ST-Link. So this is not in matching with our project name. It is still using the old name, that is template F401. So we can simply delete this folder, delete this file, because STM32 cube id is smart enough to create a new launch configuration when we launch this project for debug session. Let us delete that. Now I think everything is okay, and we will start building our application from here, from this template. Now let us download Mbed TLS. For that, go to this GitHub repo. But here one thing you have to note, that it has some auto generated files. So these are the generated source file in the development branch. The source code of Mbed TLS includes some files that are automatically generated by scripts whose contents depend wholly only on Mbed TLS source and not on the platform. So you have to, when you if you clone it using a git repo, using a git clone command from here, if you use this URL, and you will use a git clone command in your terminal, like git clone, if you use the command like git clone and then this URL, so this way you will be going to be having some problems, because the original development branch does not have the generated files, and we also need the generated files. So here they are mentioning that about the generated source file. So they are telling that uh, and to generate those auto generated file, you will need Perl, Python, you have to execute scripts. So this will be going to take unnecessary times. We are not interested in this. So the other option is to, what we can do, we can simply use git. We can go to the this releases section from here. So here you can see that it has 66 releases, and if we download the compressed package from this release section, it will have those auto generated files, so it will be easier to compile. So I will go for this option, and here I can, on Windows platform, I will download the source.zip, uh, this one. So I'm downloading the very latest version, that is 3.6.2, and then you will have a lots of files and folder here in this package. You have to extract all of these. So I have already extracted these files, and they are here. I have kept it here in this location. Now let us go back to the STM32 cube id, and here is my project, that is TLS client F401 for F401. And let us have a look at the structure. This time I have modified the structure a bit, and what I have done, I have kept the Visnet IO driver here in the drivers folder and not inside the core folder as I was doing previously. Previously I was keeping it here along with our application source code. So all the application level source code, the code that are specific to that application, are here in the src directory, and I was using this STM32 Visnet IO driver here in the source directory. But this time I have make this my application source directory a bit more cleaner, and I'm not keeping this Visnet IO driver here in the source folder. Rather, I am keeping it here grouped in the driver section, where we are also having the STM32 HAL driver and the CMSys driver. And this time I have also changed the name of the top level directory. I have named it Visnet underscore IO driver, and the naming convention I have copied this one, whatever the ST is using, that means the first character is capital and they are separated by underscore like this. So these are looking identical. Similar naming convention I have used, coding convention, everything. So here inside this I have our this configuration file, this Visnet SPI drivers. These are the actual Visnet IO driver, the socket.c and socket.h, and this is the low level driver for W5500, because I am specifically using this chip, that is W5500, and these are the supporting codes. And as this template, I am using the template from my previous example, that is DNS, or the domain name service protocol. And I'm using this template because I will be needing DNS and DHCP in this project, and that is why I am using this template. And along with this I also have MQTT, and by mistake I have also created the TLS file, but this I have to show how to do. So I will delete this file here, because in my actual template I have also kept support for TLS. So I will be teaching you how to create this. That is why for the time being I am deleting this folder. Now let us begin. So what we will do, first we have to go inside from the top level of our this directory structure of our project. We have to go inside this driver section, and if you are using my older template, then you have to go to the core section and the source section. And inside this we will be having a Visnet IO driver, and since this TLS will be a part of this Visnet IO driver, that is why we will create put all the related files here inside the Visnet IO driver, or the internet offload driver. This is not IO, it does not means input output, but it means internet offload. So let us create a new directory for our TLS related files and infrastructure. So let us name this a generic name, that is TLS. So this will have all the files that is required for TLS support, and this our Mbed TLS is just one part of it. We will also need the glue code to make this Mbed TLS work in our given specific platform, because Mbed TLS, like any other embedded library, it is a pure C code. It is not bound to any hardware or any platform. That we have to do, that is our responsibility. And in this case of this TLS, that code is very small, so that is not a big problem. And inside this we will create another subdirectory, and we will name it specifically, and this time we will name it Mbed TLS. So this is a proper noun or a proper name, but the first one was a common name. Inside this we will keep the actual source code of the Mbed TLS library, and here is my Mbed TLS library on my file system like this. And here are lots of files and directories, but please don't get confused with this. The only thing we need is this directory, that is the library directory, and the include directory, nothing else. These two things are important. So, and we have to include these two files in our project. So we will select both of them in our this explorer, Windows Explorer, and from there we will begin the drag. I am starting to drag these two files, that is the include and library, and I'm going to drop them here in my STM32 cube ID and inside this newly created folder, that is Mbed TLS. And we have to select this option, that is copy files and folder. And here we go. This is imported in our project include and library. And as we are doing every time, that whenever we create a new folder in our project, we have to include that in the list of search path that our compiler is using. And here are the settings for my GCC compiler, and inside this include path we have to include these newly created directories. And here we go, using this add button. Here is a small green add icon. Click this, put the path name of the newly created folder, and we can see it is double dot then forward slash drivers visnet io driver slash TLS. So this is the top level directory for the TLS system, and we have like this. Just click OK. Now you can see it is added here. You can also move it downwards like this. And we need one more folder. Let us see. And it is this one, include mbed tls dot include. So it is inside this TLS top level, this TLS folder, like TLS slash what we have to put mbed TLS, and then it's include directory like this. Let us once again confirm the spellings. Mbed TLS under forward slash include. Great. Move it downwards. So that it looks much cleaner and it is much arranged. Arrangement is an important tool when you are doing such complicated tasks like embedded development. Now we are done. And for the reference of the implementation, I have used this project. Just go to Google or any other search engine and then search for this, that is W5500 TLS example. So you will land on this page, and this page is by Visnet, that means the official company that is producing the W5500 chip. So they have released an example, but the problem is that this is 6 years old and more than that. They have, this is very old and not been updated, and when I followed this, it was not at all running, and this is due to the fact that several things have changed over the years, and my server was simply rejecting this SSL request. And the algorithms and the cipher suits that sweet and the algorithms and the cipher suites that these were using, they were too old, and my server was rejecting the handshake. The TLS handshake was not happening, and also it was using a very old version of Mbed TLS. Now let us have a look at that. So here they are using this version, that is Mbed TLS 2.16, but we are using version 3. So this is very old version of Mbed TLS, and it is better to switch to a latest version when I am creating the project. So one of my aim is to get rid of this old version and use the newer version. So I had some problem porting from this version to the newer version, and we will discuss all this thing in this video, and we will solve all the hurdles and get the latest version of Mbed TLS up and running in our STM32 platform. But we will use this project as a reference, so better we should also download this project. And from now on I will refer to this project as the TLS example by Visnet. So whenever I tell that copy this file from the project Visnet example for TLS, then you should understand that I am referring to the files from this project, that is the this Visnet TLS example project. So now let us begin. Let us download this also for our reference, and this will help us create the glue code that will glue our this Mbed TLS this library to our platform, which is based on W5500. Just download the zip and extract it, and inside this True Studio we will refer to some of the main main.c, and then after drivers TLS. So here is the original TLS source, and since we have already created this folder and we have replaced this with the latest version of Mbed TLS, we will not be needing this directory. We will only be needing these things. And after I have completed running this example, but I think that this example code that is provided by Visnet, that this is not very proper example. It has few bugs, it has lots of problems that we will rectify in the future and create a robust implementation. And we will discuss what are the problems in this library and this glue code. We will improve it, we will clean it, we will make it more robust, more readable. And these files are most important for us, and these are the SSL underscore random.h, SSL underscore random.c, and most important the SSL interface. So this code, this glue code interfaces our embedded TLS library to W5500's this IO driver API calls. So it integrates everything, and we have a this SSL config file. So this is the configuration file for Mbed TLS, and this is a highly configurable platform, and we will have a dedicated lesson on its configuration. For the time being, just understand that this configuration file configures embedded TLS to suit our needs. And again from here we are getting a reference implementation that works, so we will build upon this. But actually this configuration also does not work because this is a very old configuration, and I have done lots of investigations and this diagnostics to get actual working configuration file. And we are gonna cover everything in this tutorial, this video tutorial, so stay tuned. So let us extract all these files. So here I have extracted in my local file system, and here is my original IO or internet offload this driver, and just next to it I am placing this example, this reference example. And now from here we will be needing some files, and these are inside this True Studio, inside this drivers directory TLS. So here we are also having a certificate file. This is this CER file is a certificate file, and this is the we will have a dedicated lesson on this to understand what are certificates and why we need them. For the time being, just understand that we need a certificate of a root CA. CA stands for certificate authority, which issues certificates to our SSL website, and these certificates are used to encrypt the connection. So when a client connects with a server, this in the handshake phase the server send us its this certificate, but we cannot just trust any certificate for and that is the main motive or the motto of this whole system, this HTTPS or this encryption things, to build a trust. So whenever the server sends a certificate, we have to verify it that this certificate has not been modified, that means it has proper signature, and this signature is provided by a root certificate authority. so that we have we know that this certificate is authentic and it is not modified, and we can trust the server. Whatever the server is telling, it is true. and, and for that we need a certificate, the certificate of the root CA which has signed our certificate, the certificate of our web server, the certificate which is providing SSL connection to our web server. So I will teach you, I will tell you how I have obtained the certificate. So the certificate which is coming with this example, it will not work for our case. We have to get a new certificate, and I will tell you how to do that. And this is the original certificate file in the .cer format, and this header file is created from this file. Because we cannot directly include this in our C source file, we have to convert it into a header file in form of a static or a constant variable. So just let me show you. So what they do, they just create a constant which is of type character, and then have a variable, actually an array, and there they keep the content of this certificate. So these certificates are base 64 encoded, and base 64 is a technique to convert binary data in a textual form like this. So this is actually a textual form. So this I will keep a lesson on my that is the course. I will keep a lesson on this base 64 encoding. You can go and refer to that section. For time being, just understand that this is a method to encode binary data in form of text. So this is base 64 encoded actual content of the certificate in form of a C variable, so that it can be referred as a memory location. Now it's time to add the glue code. That means the code that connects our IO driver to the Mbed TLS library. And for that, I will be using the reference code that is provided by Visnet. And here I am in the folder, inside the folder. Go inside the drivers folder, TLS, and these are the glue code files. And I will copy these files like the SSL random, the C and H pair, the configuration file, and the SSL interface. I will select all of them. Let me select the certificate also, and later on we will be editing this file certificate.h to modify and change the certificate that is provided by Visnet, and we will update it with our certificate, the certificate that is valid for the site which we are trying to connect. Let us drag these 6 files and drop it in our STM32 cube ID. Here I will drop it here, not inside Mbed TLS but inside this top level directory, that is TLS. I will select the option copy files, hit OK, and here we have all the glue code files. These are the files, these have the glue code that will tie our embedded SSL with this Mbed TLS with our IO driver. So this file, this certificate.h file, it is having the root certificate authority CA file, and it is in form of this variable. I have already discussed this. And then we have the SSL random.c and SSL random.h files. So basically these two files, it provides random number generation support to Mbed TLS, and right now they are using this built-in function or the standard library function srand and rand. So as you may be knowing that these are the part of C language standard library, and they are contained within this stdlib. But let me tell you one thing here, that this implementation is not the best implementation. Why it is not the best implementation? Because these library functions, this this rand random number generation function, which is contained within the C standard library, it generates pseudo random numbers, not true random numbers. So we can confirm this fact from here. If we go to, we can search like this. We will go to this website, that is CPP reference. So here you can see the term that it returns a pseudo random number. So pseudo means anything which is not true. So it is not actually a pseudo random number. It will always generate the same sequence of random numbers. So this is not the preferred way when you are deploying the code to production. So this is just kind of like proof of concept code, just working code. Later on, what I will do, I will use the hardware random number generator that is present inside some STM32 microcontroller to generate true random numbers. So for time being, we are using this function to, and this the plus point of using this function is that it simplifies the code. And when the first time we are interfacing with Mbed TLS library, we will prefer to use something which is small and simple. So this file is very small, SSL random, this file is very small. Only two functions are there, one is random seeding and another is this SSL random CB, and this is the private function, and I think random it is generating as rand like this. So basically one function is only useful here, which generates a random number. And then we have the SSL configuration. So this file is actually configuring our Mbed TLS library. But here we have to do one important setting. Now somehow we have to specify this Mbed TLS. We have to instruct Mbed TLS to use this configuration file instead of the default configuration file. If you see, Mbed TLS also have a integrated this configuration file default. You can find it here. So these are some of the configuration files, and for that we have to define a constant. We can do it from here, preprocessor. We have to define a symbol, and this symbol will be like this. We have to provide embed tls underscore config file equal to ssl config.h. So this will instruct our embed tls to use this file, and this file is here. It is here, ssl config.h. Added. Apply and close. Now it will use that file, and now we have to do some modification to the default glue code. And TLS, so I think we are inside ssl interface.h. So just first open this file which is inside TLS and ssl interface.h, and here you might find some errors because these glue codes, they were designed for the previous version of Mbed TLS, but right now we have upgraded our this version of embedded TLS, so this makes this file incompatible. And first thing, you will see a error here, that is where it is including the compatibility layer for version 1.3. so this is a too old version, so we have to remove this compatibility thing. And then for debugging purposes, I recommend you to increase the debug level, By default they have provided 2, so change it to 5 so that we have more in-depth information about debugging. If anything fails, we will have a clear idea why it is failing. So here they are providing some basic functions like initialization functions. All these functions before, here if you see, after we have changed the debug level, we have some data structure, and this is the main data structure. So they have created a data structure, I mean the Viznet have created a data structure called Viz TLS context. So this is the central context which holds all type of different information regarding a secure socket. So it has some member, it has debugging, it has the actual SSL context, configuration context, and the certificate also. So all these things are grouped in a single data structure: the certificate, the configuration, and the actual SSL context. They have grouped in this data structure. Please remember the name Viz TLS context. And these function, that is Viz net, receive, and send, these are private function. We don't need to call directly this function. These are actually the callback function which Mbed TLS will call to get its job done in our platform. And here are the public function, that means the exported functions which we as the user are interested. And these are the initialization function. First one is the initialization function, dinit function, connect function, TLS read and write function, certificate verification function. And these are actually, after when we are using a secure socket like SSL or TLS, we don't use the direct socket calls, that means the connect or the send or receive function. In place of those functions, we have to use these functions. So these function will work in our behalf, and these will internally use those socket, and but before sending the data, they will encrypt the data so that no one will be able, means any hacker or someone who can grab your data using proper equipments, but they will not be able to figure out the contents of your messages, anything, any secure information like credit card information, shopping cart, banking information, passwords, or even your chats. They will not be able to decrypt or retrieve the actual information, like credit card number or your actual password or your actual text messages from that, that means captured data. They will be able to capture the data, but they will not be able to make any meaning of the data. So actually these function, the SSL work, these are the high level function, and we have to call these function. When we want to read the data, we have to call read. When we want to write the data, we have to call TLS write. And when we want to connect, we have to call this connect function. We So like this, we have to use this high level function that will do the handshake, the SSL handshake, the TLS handshake, or actual this data encryption and decryption, they will do internally for us. And you should notice that all this function, the first parameter is this structure, that is with TLS context and a pointer to that. All of this function, the first parameter should be the TLS context that I have just discussed here, the very first data structure. And this data structure is composed of various Mbed TLS structures, and they have grouped all this Mbed TLS structure into a single structure called Viznet TLS context. And in our application code, we have to include only this file, that is the SSL interface.h, and then we can call these functions. And now let us do some modification to this code. Go to this SSL config.h, and in the very bottom they are including this file check config. So in the newer version this is not required, and it is not recommended to include this file manually, and I can confirm the fact from here. If you go inside this file, that is checkconfig.h of the latest version, you will see this message: do not include embed tls /checkconfig file manually. this may cause errors, and this is included automatically at the right position since Mbed version 3.0. So to make it compatible with TLS version 3.0, I have to remove this thing. You can remove or comment this. I am just deleting this line. And then let us write some application code. And for that, let me see, I have missed some files that I have to copy. So it is a very small file called hextrans. So let us see. So this is the folder of the Visnet TLS example, and I have to get some file from the src directory, and this file is the hextrans.c file, and I have to drag it from here and copy it to this I have to include core and src. Here I have to put the file. I have not shown you the step, that is why I am showing this, because I am already having this file hextrans.h. It is, and in the same way you have to copy the header file also. So I have already done this. This is an important step. Now let us write the application code. So in your main.c file, first you have to include only these two files, and this file will be used later on. So let us start with just the single header file, that is SSL interface.h. So we have to include only a single SSL interface file. We don't have to access Mbed TLS directly. It will be done through this SSL interface only. Now let us open our main.c file, and there in the user code section, make sure you place any code inside the user code begin and user code end tags only. Otherwise they will be overwritten by this cube id when you generate the code once again. So till now I have the files up to DHCP and DNS, and after that we will add the support for TLS like this, and we will include this file, that is ssl interface.h. And you should be familiar with all this code. These codes have been previously discussed in this video course. Each and every line has been discussed in details, and you when you are came to this point, that means you are implementing TLS, you are expected to completed all these things successfully in your system, then only move on to this TLS section. So here also we have this user code begin and user code end section, and here we will create a data structure. We will define this thing, this structure with TLS context that I have just discussed, so which was declared in the header file that we have just included here, ssl interface.h. So this is the main handle of our TLS, or a socket that is secured, that is encrypted. So this is the main handle to this thing, and this is not a pointer type, this is actual data structure. And after that what we will do, so here since I have started with this template example code, so this message is something like this, W5500 DHCP test. So we will change this, update this, and we will change it to W5500 TLS test. So this will be more meaningful, and we will not modify any code here. Only at the end we will start coding the TLS part. So this is on line 187, we have successfully received the IP address of our server using DNS or the domain name server protocol, and I have a dedicated lecture on that, so please go and refer to that lecture. And from there, so when our code has reached this point, that is line 187, it has acquired the IP address of our server. So here you can put the server which you wish to connect. Here you can see, so it is the remote host. So this is the name of the server. For testing I am using my own server, and it is located at test.iotens.com, and this iotens.com is my brand for IoT related products, software and hardware products. So let us see, if you go to this URL, what happens. So here I have placed a simple message, and this is the message, that this message is secured by HTTPS. So when requesting, you should use HTTPS colon slash like this. And if you are using this Avast antivirus, please disable it for a while, otherwise it modifies the certificate. And then request this page once again. HTTPS, I have put double colon. So here it is, and you can see this padlock icon here. That means this site is secured, it is encrypted. If you hover your mouse over here, it will say that verified by Let's Encrypt. So this Let's Encrypt is a service which provide us free SSL certificates, free SSL or TLS certificates. Otherwise you can go for paid option also. Right now for testing purposes I am using a free certificate, free SSL certificate. So this confirms that this URL is running securely, and this is a simple message that it is delivering to us. So I am using this URL for testing. You can put some other URL here, or if you don't have your URL ready, you can test it with my URL. And we will perform a DNS lookup to get the IP address of this URL, and this will be stored in this array. Here it will be stored. So when we have reached this point, we have already successfully performed the DNS lookup, and we are also already having the IP address of our server, and we are all ready to connect using SSL or TLS. Great. And from here onwards we will start coding the TLS part. And for the demonstration, we will the very first step is the connect call, and this is achieved using this Wiz TLS connect function. So I will copy paste this code. This is my reference file. That means I have already created, I have done all sort of R&D research, means research on this topic, and I have successfully created a working code, and from there I'm copying and showing you the step so that you can also do the same. And this was my reference implementation that I have implemented and fully tested yesterday, and I'm copying from there. And I will just put it, make sure you put it before this user code end section. Oh, I have missed this point. We also have to call the this TLS init also. Right now I'm making a bit of quick and dirty code. Later on we will make everything clean and robust. Now our aim is to get Mbed TLS up and running. Then afterward we will do all the cleanup tasks. For example, here I am not checking the return value from this function. So obviously this is a very quick and dirty code. So very first call that we will issue is the embed TLS init, and here we will pass the address of this TLS context that we have just created here. And one thing we have missed, that this is the server FD or the file descriptor. So this is nothing, this is just a simple integer that is telling us which socket to use. As we all know that W5500 internally it has some TCP and UDP sockets. So this is the ID which socket to use. So it has internally, it has 8 sockets and we are using one of them. So this is this server FD. So we also have to define this variable, that is server fd equal to, and the return also, this thing we have to do at the very top of the code. Done. Now let us try to compile this code. But before that I have to do one more modification, and this modification will be done to the SSL config.h file. And I have made a note for this. Let me refer to my notes. This is my note. While working I always create the notes of the steps. So when I ran into some problem, I fixed the problem and I have noted it down. So what it is telling that in the file ssl config.h on line number 88, this define embed TLS MPI max size, we have to increase this. Let us see this where it is. Line number here I am on this file, that is ssl config.h. Let us go to the line 88. So here it is, line 88 define. We have embed TLS MIPI size, this one 256. So we have to increase this. So why I had to increase this, let me also share my experience. So when it was set to this 256, since I have already told that this code is very old, about 6 to 7 year old. So at that time the size of the key was small. Right now if you go to Firefox, you click this padlock icon and then click this connection is secure. If you click this more information, this option here, so it will show you something like this. It will gives you some detail about the certificate, and here we have to click view certificate. So it will show you the details about the certificate, and go to this section, that is public key info. And here you can see that this public key information, it is using a key size of this thing 2048. So whenever we are talking about cryptography and something is written like this, so it always means bits. So it is 2048 bits. The size of our public key is 204, and earlier it used to be a lot less. And every time new security standards are developed, they increase the key size. And one more thing I have to share, let me show you one more thing, that which version of TLS we are using. So here you can see that it is using TLS version 1.2, but this is not the latest version of TLS 1.2 is not the latest version of TLS. So let us do some research and find out what is the latest version of TLS. So here you can see that the latest version of transport layer security TLS is version 1.3. So why my Firefox is using this older version of TLS 1.2? This is because I have instructed Firefox to use this version of TLS. And there was a reason why I instructed Firefox, because currently in my this Mbed TLS, because I am teaching the user who are using Mbed TLS for the first time, so I want to keep the things as simple as possible. So I am not using TLS version 1.3, because that takes a lot more step. It is not just a simple minor version upgrade. It is lot more complex than TLS version 1.2. So that is the reason I am using. And to check everything, I have also set my Firefox to use this version of TLS. And how I have done that? For that, I have opened a new tab, and then I have gone to a special address, and this address is about this about colon config. So it will alert you that proceed with caution. And here you have to search this term TLS, and here you can see one option, that's security.tls.version max. So by default in your browser it is set to 4, but you can edit and change it to 3. uh, One more thing, the version number does not match directly with this version number, so there is also a reason for that. So actually this version 3.3 corresponds to TLS version 1.2, and TLS version 3.4 corresponds to version this 1.3. So you can check about this in Google, you can search it. Internally it is referred by different numbering in the SSL protocol. Actually this in SSL protocol, uh, uh, this TLS version 1.3, it is actually referred by a version number of 3.3, because SSL is also included in that means in that byte position. So the naming convention, this numbering is something like that. For that I have a URL, I will share with you. So I think this video is getting too long, and I am thinking of splitting this in two parts. So I am ending this first part here, and tomorrow we will continue with the part 2 of this video. So thanks for watching. See you in the next video.